All right, this is the teaching on lesson 11.3, and it's the areas of regular polygons. And polygons are like hexagons, pentagons, heptagons, octagons, but they all have congruent sides. Any polygon can be looked at as being divided into triangles, and those triangles all have the same size. The area of a polygon is 1/2 the perimeter times the apothem. Well, you know what the perimeter is. The perimeter is the distance around something. Okay, so typically they're going to give you the perimeter, like for instance on this first problem, they tell me the perimeter of this regular pentagon is 40 centimeters. So I can figure out what each of those sides are by taking the 40 and dividing it by 5, and I find out that each side is 8 centimeters. The problem is what that A is. A is called the apothem. An apothem is the line drawn from the center of the circle straight down perpendicular to the other side. The apothem not only bisects the angle, but it also bisects the side, so I can assume that that's 4 and that's 4. So how do I figure out the angles there? The angle, I know that this plus this plus this plus this, those central angles add up to 360 degrees. So if I take 360 and I divide it by my 5 angles that I have, I'm going to find out each of those angles is 72 degrees. So when I cut it in half by drawing my apothem, that angle right there is 36 degrees. So if I draw this triangle out, so I'm going to take this triangle and put it down here. I'm going to use what I know about trig to figure out the apothem right there. So I know that this is 4, and I'm trying to find A. So remember, opposite and adjacent is tangent. So the tangent of 36 degrees is equal to 4 over A. Remember, we have to get the A off the bottom. So we multiply both sides by A. So I have A times the tangent of 36 is equal to 4, and then I would divide both sides by the tangent of 36. So A, or the apothem, is 4 divided by the tangent of 36, or 5.5 centimeters. All right, so now I have everything I need in order to find the area of this pentagon. Area is equal to 1/2 times the apothem, which is 5.5, times the perimeter, which is 40. And that's going to give me an answer of an area being 110. Now remember, it's going to be whatever the units are squared because it's the area. Okay, now I'm going to give you one a try. Might just leave that particular one up there and change some of this. So this time I have a regular pentagon and my perimeter is 90. So go ahead and do the problem, pause the video, and then come back and check your answer. Okay, my central angles are going to be the same on this, so each one of these is going to be 72. So again, I've got those done out. I need to know what each of these sides are, so I have 90 divided by 5. So each side is 18, and I have to know that in order to know down here that each one of those is 9. So here's my triangle that I'm going to use to find my apothem. I have 36. I have 9, and I need A. So again, tangent of 36 degrees is equal to 9 over A. You would continue to work it out. Figure out that A is equal to 9 divided by the tangent of 36 degrees. Okay, and that's going to give me 12.4, which I'm going to turn around and use over here. So I have 1/2 90 times 12.4, and that's going to give me 558. If they don't give me what measurement it is, I'm just going to put units squared. If they had given me that as inches, it would have been inches squared or so forth, just depending on what they give you. Now, you might be a little bit off here because it depends on where you've rounded through. So just, you're going to be close. All right, now we're going to move on to a circle. You know the area of the circle, but as you might guess, it's not going to be just a normal circle. The area of a circle is pi r squared, with r being the radius. So we're going to combine circles here. Let's say I have a table, and that table is 48 inches across, and the table is 34 inches high, and I want a tablecloth that's going to cover the table and go all the way to the floor, and I want it in yards squared. Well, that's going to be a problem because this particular thing is in inches. So somehow I'm going to have to convert between yards and inches. So I'm going to go ahead and talk about that right now. If this is 1 yard by 1 yard, there's 36 inches per yard. So to figure out how many square inches is in a yard, I'm going to take 36 times 36. And I'm going to find that 1 square yard is equal to 1,296 inches squared. All right, so that's going to be important. Here I got to think about what the radius of this circle is. So half of 48 is 24. So basically what I have is I have a radius of 24 plus 34, which is going to give me 58, which of course I'm going to have to square. And when I work that out, I find the area of this whole thing is 10,568.3 inches squared. But remember, we talked about we have to change the inches to yards. So you're going to have to do dimensional analysis here. So 10,568.3 inches has to be changed to yards. So I want to get rid of the inches. I hope you can still see this on the video, and this is going to be yards squared. So the 1,296 is going to go on the bottom, and the 1's going to go on the top. So basically my answer is going to be derived from taking this divided by that, and it's going to give me 8.2 yards squared. All right, now I want you to try one. This time we have an umbrella company that's going to cover our umbrella with material, plus there's going to have material hang down. This is going to be changed to 72 inches. And the amount that is hung down, and obviously this isn't to scale, is 8 inches. So go ahead and find in square yards how much material I would need. Okay, so go ahead and work that out and then come back and check your answer. All right, half of this is going to be 36, so I have 36 plus 8, which is 44, so that's going to go right there as my radius. When I multiply that out, I'm going to get 6,079.04, and this is going to be inches squared. Now again, I'm going to have to convert from inches squared to yards squared. I have this conversion, so inches squared is going to go on the bottom, so that's 1,296 on the bottom and 1 on the top. So basically I'm dividing this 6,079.04 by 1,296, and I'm going to get an answer of 4.7 yards squared. All right, then we're going to combine these two things. We're going to put not just the circles, but we're going to combine shapes, and we're going to do circles and triangles, and of course put them together. So let's say I have this circle, and I have an equilateral triangle drawn in the circle. Doesn't look equilateral, but you can pretend. And I want to know the area of the shaded region. Well, I got to have a plan. My plan is the area of the circle minus the area of the triangle. And that would leave the shaded region. It does tell me, let me see, tells me that from here to here is 4 centimeters. That's about all I know. That's enough to tell me the area of the circle. So the circle is going to be pi r squared, where the r is the 4, so pi times 16. So the area of the circle is 50.3. The triangle is what presents the problem. So I'm going to bring the triangle down here. Okay, now remember, it can be divided into 3 triangles. And I'm just pulling one triangle down. So I have 360 divided by 3. I know that this right here is going to be 120. So each of those central angles is 120. I'm going to go ahead and make a line straight down because that will allow me to find the base of the triangle, which I need. So the area of the triangle is 1/2 the base times the height. So I don't have the base and I don't have the height. I know part of the height is 4. I just got to find that other part. So this triangle comes down here. I know that this is 4 and this is 4, but I don't know anything else. So half of the 120 is 60. And you could, if you wanted to, you could do special case triangles here, but I'm guessing you will do trig, so that's what we're going to go forward with. I need to know x, and I need to know a, because the base is going to be this whole thing. So let's say I've got opposite and a hypotenuse. The sine of 60 is equal to x over 4. So I'm going to multiply both sides by 4. And I'm going to get 4 times the sine of 60 is going to give me approximately 3.5. So the base here is going to be 7. So I have 1/2, 7. Now I just have to worry about the height. Okay, so the height of the whole thing is going to be 4 plus whatever I get there. Now at this point, you have 2 sides of a right triangle, so you could use Pythagorean theorem. So you could have 4 squared, or 16, minus 3.5 squared, and then take the square root of that. And that's going to give me approximately 1.9. So my height here is 1.9. So I have 1.9 plus the 4, let's go ahead and round it to 2. That's going to give me an answer of 6 right there as the height. If I did that correctly. That's going to give me the area of the triangle once I work that whole thing out of 42 divided by 2, which is approximately 21. I think if I left this at 1.9, it's going to give me an area of 20.8, which might be just a little bit more accurate. So it's 20.8 centimeters squared, which I'm going to subtract from that, which is going to give me an answer of 29.5 centimeters squared. And that's the area of the shaded region. All right, so I want you to try one. We'll leave the same illustration up there, but we'll change this to, let's change that to 7. Okay, so go ahead and work it out, and then come back. All right, same plan, area of the circle minus the area of the triangle. The area of the circle is going to be pi times 7 squared, because the radius here is 7. That is going to give me 153.9 centimeters squared. The area of the triangle, I have got, this is 120, so this would be 60, and this is 7 right here. So I need to know the bottom, and I need to know the top right here. So x is going to equal the sine, well, let's do it all out. The sine of 60 is equal to x over 7. So x is going to equal 7 times the sine of 60. So this is going to be approximately 6 right there. Actually, we'll make it 6.1 to be more accurate. Okay, so I have 1/2 the base. The base is going to be 12.2. The height I can get by doing Pythagorean theorem. So I have 49 minus 6.1 squared. And then I'm going to take the square root of that, which is going to be approximately 3.4. Okay, when I multiply that whole thing together, and again, it depends on where you round it, it's approximately 63.7 centimeters squared that I'm going to subtract from my area of my circle to get an area of the shaded region of 90.2 centimeters squared. All right, your homework on this. And I would encourage you to go back and watch the video again, or watch parts of it if you get confused. Or if you have a question, just text me, show me the problem you're on, and I'll text you back how to do it so that you can continue on with your homework. So page 613, 8 through 42 even, and it will be due tomorrow, which is Tuesday at noon.